Here, I'm going to go ahead and make this one the one I record then, so I can have the video answered post. All right, so the question is this. We've got three vectors to add together, right? And we're looking for the resultant. So it goes kind of like this. A plus B plus C has to equal our resultant when you add your vectors together, right? A, the actual parts of A, it's going to have its own X and Y, right? So AX plus AY is A, right? BX plus BY is B, because it's going to have an X and Y. And C's X plus C's Y has to be whatever C is. And all of that stuff added together is still A. So the RX, in other words, the X component of R is going to be all the X's added together, right? The Y component of R is going to be all the Y's added together. So this is a two-step problem. Step one, we got to find out what those things are. And then step two, you've got to find the sum of the X's and Y's. So the sigma of X and the sigma of Y. All right. So it goes kind of like this. A is a vector that is just pointing 3 newtons to the east. I know that newtons is our unit here. We're not even worried about units at the moment. We're just worried about the number 3. It's 3 to the left on this diagram. Please put your phone up. Please put your phone up. That's great. Thank you. Hey, 3 to the left. Does it have a Y component at all? Is it going up and down at all? No. So this first one has a Y component of 0. What about the X? How big is that leftward arrow? 3. Now, since it's pointing to the left, I'm going to be careful and write it as a -3. Okay. For B and C, though, it's not so simple. You've got the hypotenuse of a triangle. You have a hypotenuse and a given angle. So what you have to do, here's the vector for B. 7 long and 25 above the positive X direction, or 25 above east. Turn it into a triangle. So here's the triangle you get. 7 and a 25-degree angle. Solving for the other 2 sides of the triangle. And our strategy for doing that is either sine, cosine, or tangent. So in the case of B, on the X side of this triangle is the thing that is adjacent to the 25-degree angle, right? So that means that B, we got the cosine, because cosine is adjacent over hypotenuse, of 25. And it's going to be equal to our missing X over our given hypotenuse, which is 7. Or in other words, cosine of 25 times 7 should be whatever X for B is. So what you do at that point is you throw it in the calculator, go ahead and get the cosine of 25 and hit enter. And then take whatever that is, and we're solving for X using algebra, so that's why it's multiplied by 7 to get rid of that 7. Looks like the X component of B is 6.3. We'll just call it 6.3 for now. All right, well, let's go ahead and get that 4. Why not? Why not? Just in case. We might need it. All right. Same kind of procedure to get the Y, the upward component of B. But instead of cosine, it's going to be sine. So take a second, use your calculator. The sine of 25 degrees is this opposite divided by that same hypotenuse. So go ahead and ask your calculator for the sine of 25. Hit sine 25 and then hit enter. And then just like before, algebra says we got to multiply by 7. So sine 25, hit enter, times 7, hit enter. And you'll get the Y component for B. I got 2.95, blah, blah, blah. If I kept 3 digits here just in case for precision, maybe we should keep 3 digits on this one. 2.95. And then for the rounding, you look at the next digit. The next digit's an 8. So would we keep that as 2.95 or would we round up to 2.96? Just in case, let's write it as 2.96 right now, because I think the precision of our answer, because we only have limited choices, we might need to be really careful. Okay, so are these positive or negative? We're going to the right. I'm gonna go ahead and put an arrowhead on that so you can see that we're going to the right. And we're going up. So are we going in the positive or the negative X direction? Positive, so this is gonna be positive. Are we going in the positive or negative Y direction? So these two are both positive, okay? Same procedure for C. Before you solve C, it has an X and a Y, right? But they're flipped. So is that a positive or a negative X? Is it going to the right or to the left? It's going to the left. So this X is going to be negative. What about the Y? Is it going up or is it going down? It's going down. This general Cartesian coordinates, north, south, east, west goes like this. And then on a piece of paper, since we usually are graphing on a piece of paper, we assume coordinates just like in geometry class, where if you're going this way, this is the positive Y direction. If you're going this way, this is the negative Y direction. If you're going this way, the positive X, going that way, the negative X. That's just the convention. Now, your frame of reference determines what you actually do. But if they don't tell you, like, I mean, they could say that the positive direction is that way. And for that question, that can be true. Or for example, there's not really an up or down in space, but we're traveling around the sun in what we would call the positive direction, but we're actually moving in a circle. We're an oval. The positive direction is what we say it is. But if they don't give you any information, we usually assume a coordinate plane, where toward the top of the paper is Y in the positive direction, and toward the right is Y, X in the positive direction. That's just the convention. But yeah, it all depends on what we're talking about. Okay, I want you to solve for the X and the Y of C, knowing that they're going to be negative. Take a second. Similar procedure, sine and cosine. Yeah, here's what I've got. 2.46 is X from cosine, 434.434 for Y. Might as well keep 3 digits there. We might need it, right? Okay, so at this point, you've got the X and Y for all 3 vectors. You're going to add them all together, and that's the X of R. You're going to add all the Y's together, and that's the Y of R. So our 3 X's are a -3 and a positive 6.34 and a negative 2.46. Okay, our 3 Y's are a 0 and a positive 2.96 and a negative 0.434. Adding those 3. All right. Take a second and see what you get. Okay. Here's what I've got. All that added together is 0.88. It looks like it's a positive 0.88. And all of this added together is 2.53, a positive 2.53. So here's what that tells us about what that object is really going to do. If you start from here, our reference point, maybe that's the maybe that's where X and Y cross, right? So here's Y and here's X, just like in math class. What that's telling us is that you're going to travel in the X direction, positive 0.88. So you're going to go this way, 0.88, whatever's, Newton's in this case. And you're going to go up in the positive Y direction, 2.53. Not exactly to scale, but here's our new triangle, okay? So the job now, this is the X and the Y of R, and that means that this hypotenuse is R. So if I go ahead and turn that into a standalone triangle here so you can see it, the final answer, the new job, is to find out how long the R is and what angle R is, okay? Now, when I saw y'all on Monday, we found R using the Pythagorean theorem, right? R squared equals A squared plus B squared, okay? So you do have the two sides of this triangle. You do have a 0.88 and a 2.53. So let's find the magnitude of R, use the Pythagorean theorem. A can be this one if you want, B can be that one if you want. And we're going to solve for what R's length is, the length of that side. All right, ready to go. Okay, so yeah, 0.88 squared plus 2.53 squared, and the square root of whatever that is. You want to call it 2.68? Tell me if I did something wrong. I don't think I did. All right, R's length. So R is going to equal 2.68. And since the unit we were given was newtons, let's go ahead and say newtons. This is a resultant force. What will happen to an object that has multiple forces acting on it? Okay, a vector also needs direction. So how would you find the missing angle right here? When you have all the sides, you can use sine, cosine, or tangent. But if you're looking for a missing angle, it's not sine, it's arc sine. It's not cosine, it's arc cosine. It's the opposite, it's the inverses, right? So which one do you want to use? Sine, cosine, or tangent? I don't care, whichever one you want. How about sine? Because it's the easiest. It's the one that we use the most. Hey, look, the sine of this angle is going to be opposite over hypotenuse, right? We now know what the hypotenuse is. Sine of our missing angle is opposite over hypotenuse. This is the opposite, 2.53. This is the hypotenuse, 2.68. If you put into your calculator, I'm running out of room, otherwise I'd write it. Do sine minus 1, do arc sine. Sine minus 1. Give it that fraction, give it that sign. It'll tell you what the angle should be. And that'll be, hopefully, the angle of our answer. Let's see. 2.53 over 2.68. You want to call it 71? I bet you on my answer choices, I rounded to the nearest whole degree. 71 degrees. Now, that 71 degrees is relative to what? Is it the east line or the north line? This is east, right? How about 71 degrees? It's on the north side of east. What do y'all think? 71 degrees north of east is how I would probably write that. Okay, is that an answer choice? Slightly rounded. But it looks like, what do y'all think? A, B, C, or D? A, 7.1 minutes, 50 degrees above east. Hey there. Sorry. Thought it was a lot. Isn't B closest to our answer? Look at B. 2.7, they rounded to two digits, 70 degrees above east. Isn't B closest to our answer? Yeah. All right, there you go. Do we need to hold up the cards? We know what the answer is. Yeah. Okay. So that's about as hard as it gets for that.